We are back for the Quiz 6 preview that will be coming up tomorrow in class over sections 5.4 through 5.6 and a couple of review problems in from some other places sprinkled in. Simplifying expressions completely and writing in standard form. Again, just a reminder, as you are completing these, that you need to keep a couple of things in mind. Number one, when you see the negative inside, remember, pull an I out. Once you pull that I out, then if you can break down what's left over, go ahead and do that, and you're done. Notice I didn't do plus minus on this. It's not an equation like numbers 8, 9, and 10 are. So unless there's an equal sign and you're getting a quadratic, something with an x squared that you're solving for, do not put plus minus. You'll lose points that way. Okay, here's kind of a combo of new and old. On the 64, I remember, okay, I got to pull an I out. And that'll get me to 64, x to the 8th, y to the 7th. Well, I know the square root of 64 is 8. So I know that's going to come out front here with my I. But then now how does that work again with these exponents in a radical? Remember, my root out here is 2 when I don't see one. And our rule always was exponent over root. 8 divided by 2 would be 4. Okay, that all comes out clean. There's no remainder. But then I get to the y. And this is where we got to think back. When we talked about old school division, we said, okay, 7 divided by 2, 7 goes in, 2 goes into 7 3 times. Okay, so that's going to be the y to the third that gets out. However, that remainder of 1 that I get has to stay inside the radical. But that's the only part that does. So anything that's a perfect square or goes in perfectly with our long division gets out. Anything that doesn't work perfectly has to stay in. Next thing, there's lots of little details on this quiz that can really get you if you're not really paying attention. For instance, there's a big difference between numbers 3 through 5 and number 6. Numbers 3 through 5 I do not need to FOIL out. They're not multiplication. See that plus and minus in the middle? That means it's just kind of like adding like terms. Okay, and remember, the only time we can change a value is if it's I squared, not just I. So when I'm looking at these, I'm like, okay, so 4 minus 7 is negative 3. Negative 9i plus 5i is negative 4i, and that's all I can do. And again, standard form when you're working with imaginary numbers, typically it's going to be a plus bi, where the real number is first and the imaginary value is second. Same thing on number 4, except that minus is sort of like distributing a negative through. It doesn't have any impact on my first quantity, but it changes the signs on both of these. And at this point, I combine my like terms. And I'm set. So again, when it's plus or minus, I'm just combining like terms. Treat the I almost like you would treat a variable. This last one, we get a little extra distributing in. Again, 7 times 3 is 21. Do it to both terms, not just the first one. Distribute your 6 through. And now again, notice no I squareds. Just going to combine like terms. And I'm set. Now 6 is the one that I have to think a little more about, because now I'm multiplying. Now I need to FOIL this. So when I go to FOIL, I have my first, so 2 times 4 is 8. My outer, 2 times negative 7i is negative 14i. My inner, positive 12i. And my last, 3 times negative 7 is negative 21 with an I squared. Now, a couple things here. First, remember, I squared is equal to negative 1. So when we did this in class, we talked about the fact that, well, that negative 1 basically is just going to change the sign on this. So when I see negative 21 times negative 1, that really makes this a plus 21. Because that's what negative 21 times negative 1 would be. And now I can just combine like terms. 8 plus 21 is 29. Negative 14i plus 12 more is negative 2i, and I'm done. But again, you have to be able to FOIL to do that. And if you get things all mixed up again, just remember it kind of makes a face when you're doing it. 7, last one with the imaginary numbers, trying to work with them again. Just a reminder, can't have I in the denominator. Can't just miraculously say I feel like getting rid of it. Can't cancel it, okay? What I'm going to do is multiply by what's called its complex conjugate. Again, really big word, really simple concept, which basically says I'm going to switch the signs of what's in the middle for my denominator, multiply that to the top and bottom, and I'm going to FOIL both of these out. So, if I FOIL here at the top, my first would be 5 times 1, so I'd have 5. My outer, 5 times 3i is 15i. 1 times I is 1i. And my last would be a positive 3i squared. When I move to the denominator, same idea, except at the end I should end up with any I terms. But we'll see. My first, 1 times 1 is 1. 1 times 3i for my outer is 3i. Inner, negative 3i. And last, negative 3 times 3 is a negative 9i squared. So we'll take care of these one at a time. Up top, there's an I squared, which means it's just going to change the sign, so that plus 3 will become minus 3. And when I simplify that, 5 minus 3 is 2. 15i plus I would be 16i. Down below, my negative 9i squared, again with I squared being negative 1, negative 9 times negative 1 would make that a positive 9. Positive and negative 3i cancel, which they should, and 1 plus 9 is 10, but be careful. You've done an excellent job so far, but always look back to make sure with your 3 terms, is there anything that could help me reduce that? It's divisible into all 3, and this time there is one. It's 2. So if I divide all of my terms by 2, that'll get me set. And that basically gets us covered for most of our imaginary part. Now, when it comes time to solve by radical, again, my first job, first and foremost, is to try and as quickly as I can isolate my x term. I cannot just square root every time the very first step. So here, I would minus my 5, the first step. Again, I notice I still have a 2 in front of my x squared. I cannot square root this yet until I get that 2 out of there. And now I have a whole different set of issues. I finally get my x squared term isolated. I remember, oh yeah, it's a quadratic, means there's 2 answers. So when I take my square root, there's 2 things I gotta remember. One, that there's, well, of course, 2 answers, plus minus. And then once again, there's that negative. Pull that I out. I square root of 32. And then there's even one more little thing this time. I can break the radical down. The question is, are you going to get the biggest one? Well, are you? What are they? If you told me 4, it's not the biggest one. Hopefully at some point somebody said 16 here. So here, we're going to go ahead. Square root of 16 is 4, so it's going to come out with my I. And then my square root of 2 didn't break down, and I'm done. Okay, now will all of them be that way? No, not necessarily. Actually, I'm going to skip down to 10. I'll come back to 9 in just a second here. If I come down to 10, because it's similar, x squared needs to be alone first. So we'll get the 81 out of there. And just like before, it's isolated. I can square root it. Be careful. Plus or minus. Oh, there's a negative. There's my I. What's the square root of 81? You should know this off the top of your head at this point. That's right. I should be hearing like 29s coming out at this point. And that one's set. Negative numbers, pull the I out. That's the only way I can make them positive. Now number 9. Same idea, except now I've got to work on isolating my quantity, my set of parentheses. To do that, I've got to do the opposite of multiplying by -3, which is to divide. Now, again, I don't want to FOIL this. Okay, I don't want to distribute the squared. I want to get that squared out of there. So square root it. Plus or minus, because it's a quadratic. I, because of the negative. Now we need to work on breaking down that 45. Not a whole lot of options this time. Get those radicals set. And if some of you can do this in multiple steps at once, that's okay. Square root of 9 is 3. That gets to hang out with my I out here. 5 is still acting irrationally. It gets to stay under the radical. And again, when I bring the 1 over, caution, does not go with this 3. That plus minus is a wall. This little area is staying off to itself. Looks strange, but definitely the answer. Now, as you will notice, solve by completing the square. No steps, no anything. This is the point where we got to remember it, and I think you can. Just try to keep reminding yourself, okay, x squared by itself, check. Step 1, done. Get your x terms isolated on a side by themselves, done. Step 2, check. What is step 3? Okay, take your b, divide it by 2, then square it. That's the value I'm going to be adding to each side. Whatever I do to one side, I have to do to both. That's the whole idea of an equation, that we keep equality. So, 2 plus 25 is 27. And now I'm ready on this side to get my perfect binomial term. And remember the shortcut for this? I can either do a diamond on this, which means I need to find the same number that multiplies to 25 and adds to 10, which probably wouldn't take you long. Or I can just steal my b divided by 2 number, because they're one and the same. And once you get here, I know you can do it. Wipe those guys. It's a quadratic, plus minus. Question is plus minus what? And it's not the square root of 27. Break it on down. What's it going to be? That's it. Square root of 9 is 3, square root of 3. And then just bring my 5 over like we were just doing in the square root problems up above. Everything always doesn't come out all nice and pretty. And the only difference here that's going to be between 11 and 12 is that number 12, I have to do the second step, which is isolate my x squared terms. So step 1 was done. Step 2 is now done. Step 3, my b divided by 2 and squared. So again, that's going to be added to both sides. Oh dear. I was thinking ahead to what the answer was going to be once I simplified it. Details, details. X again multiplies to 49, adds to negative 14, or just use your b divided by 2. Now it should be easy street. And again, if anything else, do not forget your plus minus, because I will get you on that if you're not careful. Radical doesn't break down. Good to go. Okay. So this completing the square stuff's not bad. You don't have to have all the steps in front of you. It's just get the x's isolated. Remember your b divided by 2, and then the rest of it's pretty self-explanatory. Head to the other side here. Let's see what else we got. Identify the center and the radius of the circle by completing the square. Twice! All right. Same first step as before. I want that 24 out of there. So we'll go ahead and we'll do that. Then my second step was always to group my x's and group my y's. Now again, if you want to do steps 1 and 2 at the same time, save yourself some room or writing or whatever it is, that's fine. So x's together, y's together, constant term on the other side. Now I'm going to make myself a set of parentheses with each of these. And my blanks are going to be just like what I did on the other side with my b divided by 2 and squaring it. Except, like it says, I'm going to do it twice. So, for my x, I've got 8 divided by 2 is 4 squared is 16. Add it to both sides. My y is negative 6 divided by 2 is negative 3. Squared is 9. And again, the values you add in are always going to be positive. If you get a negative, it's because you forgot the parentheses. Never, 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 never a negative. Get these guys into their binomial form. Again, whatever my b divided by 2 was is what can go in there. Whatever my b divided by 2 was goes in with my y. 24 and 16 is 40 plus 9 is 49. And then again, my center, remember when I'm doing these, here's the general form with my center being at HK. In other words, my center is at the opposite of both of these values. So if that's the case, the opposite of 4 is negative 4. The opposite of negative 3 is 3. And this is my radius squared. And I know you're all saying it's plus minus then, but remember my radius can't be negative. So only the one that makes sense. But it is. It's the exact same parts, except it's basically like you're doing completing the square twice in one problem. Quadratic formula. Again, no signs of it anywhere. Negative b plus or minus b squared minus 4ac over 2a. In your noggin. Yeah, in your noggin. Keep track of my terms, and then again, it's the opposite of b, plus or minus the square root of b squared minus 4ac over 2a. Let's see here, 12. And again, I would suggest popping this into the calculator, just what's under the radical. Don't try to do it with the square root. You're going to mess it up. I'm just saying. So 144 minus 80 is 64. Save you a little time at home. Again, that's just what this is. Calculate it out without doing the square root yet. Well, square root of 64 is 8. So 12 plus or minus 8 over 2. And since it broke down nicely, I need to legitimately get both answers. 20 divided by 2 is 10. 4 divided by 2 is 2. And I'm set. But again, I got to know the form to be able to get there. Same thing here. Nothing fancy thrown at you. Negative b squared minus 4ac over 2a. Let's see what we've got underneath here. 36 plus 12 is 48. 48 breaks down though. So if I get a radical that can break down like this, and again, get the biggest one, that's 16 and 3. Don't go 4 and 12. You'll have to do it twice. Let's see here. Negative 6 plus or minus the square root of 16 is 4. Square root of 3 over 6. Anything else I can do with this one? You know when I ask, that typically means there is. Anything divide into those three numbers? Yeah, 2 does. So divide all those by 2. Now we're done. Moving on to our last couple of sections here. Describe a quadratic function that has. Now we discussed yesterday when we were talking about the quadratic formula how you can look at the pictures of a graph to see a little bit about the solutions that they have. And I'm actually going to pop that back up here for a minute. And we talked about the number of intercepts, explaining to me how many real solutions that there were. How if it crossed the x-axis 2 places, there was 2 solutions. If it crossed at 1 place, there was 1 solution. And we talked a little bit but didn't have a picture about what happens with 0 solutions. So that's what we're going to take a look at here for a second. One real solution basically just means it has 1x intercept. The parabola is just going to touch the x-axis 1 time. Be it. So like if I had a picture of that, it would look something like this, where it only touches in that one place. 2 real solutions means 2x intercepts, like we were talking about. So if I was drawing a picture of that one, it may look something like this, where there's 2 places that it's going through. Now this one we talked about, but we didn't really see pictorially. So let me describe this a little bit with a picture. 2 imaginary solutions. What's that mean? Well, that means there are going to be 0 x-intercepts. Well, how's that happen? Basically, I may have a graph, and it may look something like this. It never crosses the x-axis. It's going to have some solutions, but since they don't cross the x-axis with that, I wouldn't be able to figure those out in the graphing calculator. I'd have to crank those out with the quadratic formula. Okay? But that's as simple as I can make that as far as writing a description for each of those. 1 real solution, 1 intercept. 2 real solutions, 2 intercepts. 2 imaginary solutions, 0 x-intercepts, because it's never going to cross. And then one of your favorites to finish up. I don't know how I went without doing this, without doing factoring on here. Area of the rectangle shown is 152 square meters. Area is length times width. Area is length times width. Doesn't matter which order I put those in. So now I'm going to distribute that through. And no matter which way I want to do this, I'm going to go ahead and I'm going to bring the 152 over. And again, when I bring the 152 over, I have to do it with an opposite. Now, this becomes the point where we have to think a little bit. I don't have anything that factors out of this. So at this point, I have some options. Now this is just me. I don't think I'm going to be thrilled with trying to factor this, doing slide and divide and figuring out what multiplies to 456 and adds up to -5. I think that may take a while. So maybe, just maybe, I will use my newfound friend and I will say, okay, I am going to use the quadratic formula. So if I go to use that, thankfully in this case, because I seriously don't think I would want to deal with that. So I have negative b, the opposite of b, plus or minus the square root of b squared, remember those parentheses, minus 4ac all over 2a. Okay, like we did before, we're going to take a peek. Get this typed in. Okay, get that big old number and take the square root of it. Okay, came out nice. So I have 5 plus or minus 43 over 6. And again, I can break that off into its two parts. One that has the plus, one that has the minus. And let's see here. 5 plus 43 is 48. 48 divided by 6 is 8. 5 minus 43 is negative 38. Before I even hit this anymore, dimension cannot be negative, so I'm not worried about that. So I get x. Don't forget about the last part of the question. Dimensions of the rectangle. Okay, x is 8. Plug in 8 for x. 3 times 8 is 24 minus 5. 19. Whew. And that would be my dimensions. I'm going to say this just like I've said on the last couple of these. If the first writing you have done on this sheet is just copying this down in class while we're kind of watching it to see how it goes, you need to make another copy at home and try doing it on your own without your notes or without watching this. Or if there are some parts of it you haven't known, you need to go back to those sections and try some more problems, whether it's in the book, whether it's some old homework problems, whether it's an old quiz, whatever it is, and get some practice on your own, because it's always easy when someone else is telling you step to step what to do. Much harder when you've got to do it and kind of talk yourself through it. So study well and good luck.